Hey guys, I hope you're having a good evening. We're going to go ahead and start looking at three variable systems. So let's look at this problem. A convenience store sells 23 sodas one summer afternoon in 12, 16, and 20 ounce cups, small, medium, and large. The total volume of the soda sold was 376 ounces. If the prices for small, medium, and large are $1, $1.25, and $1.40 respectively, and that the total sales were $28.45, how many of each size did the store sell? So remember that when you're trying to determine what your variables are, first look at what you're comparing. So you're comparing small, medium, and large. So I'm going to go ahead and define my variables as S being how many small cups were sold. So the number of small cups sold. Okay, M, number of medium cups sold, and I'll use, you guessed it, good job, number of large cups sold. So that's what we're trying to find. How many of each size did the store sell? So first of all, let's look at the different totals. It says that the convenience store sells 23. So obviously S plus M plus L equals 23. Now the price of a small is $1. So 1S plus the medium is $1.25. Remember, these are rates. And the large is $1.40. So the prices add up to the total sales, which is $28.45. Okay? Finally, we have to look at this other number in here, which is the volume, 376 ounces. So we have 12, 16, and 20 ounce cups. So the number of ounces in a small is 12. So 12 ounces times the number of small cups. That will give you the volume of your small cups. 16 times the number of your medium cups will give you the volume, the total volume of your medium cups. And again, 20 times large cups, total volume 376. The next thing I want to cover is how to write a matrix. If I can spell, we're going to write a matrix using this. You should remember this a little bit from Algebra 1, hopefully. So we use a large bracket so that we can fit 3 equations. And starting off with our first equation, we write down the coefficients on each letter. So we have a 1, and a 1. Leave a space between each one, and then the constant goes on the end. Next equation, coefficient 1, 1.25, 1.40, 28.45. And finally, the last equation, 12, 16, 20, 376. And there's our matrix for a 3-variable system. And the next thing I will be teaching you in the near future is how to solve this. And the method that we're going to be using is called the Gaussian elimination method. And we're going to have a lot of fun. Okay, let's look at example 2. So I'm going to go ahead and let you read it. So please pause the video right now and read the example. Okay, welcome back. So defining our variables. So it says here, how many sophomores, juniors, and seniors attend this high school? So we need a variable to represent the number of sophomores. I'm going to go ahead and use S for the number of sophomores. I'm going to go ahead and use J to represent the number of juniors. And I'm going to go ahead and use, I think I'm just going to use R for seniors. Number of seniors. Okay. Next, we're going to set up our equations. So, we had 40% sophomores. To change a percent to a decimal, you have to move the decimal 2 places to the left. So this is going to be 0.4 times sophomores plus 0.8 juniors plus 0.8 seniors. Okay, and this is the homecoming dance. We have to look for the total for homecoming. Down here, the attendance for homecoming was 488. Total, sophomores, juniors, seniors. Equation 2. So we had 80% sophomores, 40% juniors, 40% seniors. Notice I'm using the decimal equivalent of 40%, which is 0.4. And this was MORP, whatever that is, equals 412. All right, next we have prom. 50%, 70%, 80% total. Have this equation done for tomorrow and write the matrix. Finish the matrix. Hope you're having a good evening. I'll see you in class tomorrow.